Hello and welcome to Algebra 1, Chapter 4. We're going to do 4.1 today, but we're going to introduce Chapter 4 here. And it's called Analyzing Linear Equations. And remember what linear should make you think of. So, just so you know what you're going to learn throughout the whole chapter is we're going to find the slope of a line. We're going to write equations in slope-intercept form and in point-slope form. We're going to write equations for parallel and perpendicular lines, and we're also going to draw scatter plots and write equations for lines of best fit. And if there's some of that you don't know, hopefully by the end of chapter 4 you will. So 4.1 is just on rate of change and slope, and in fact rate of change and slope are the exact same thing. It's just what context you'd use which word in. So most often in the real world we're going to talk about rate of change, but in math class we're going to talk about slope. So our goals for this section is we're going to use the rate of change to solve a problem, and we're going to find the slope of a line. So let's get started. So rate of change is just a ratio that describes how much one quantity changes with respect to another quantity. And when we talk about it in terms of a graph, we're going to talk about it as the change in y over the change in x. And we've talked about that change in is delta, it's the triangle, delta y over delta x. So if we're looking at this graph here, we have walking times and distances walked. And what is the x going up by? Going up by 1. What is the y going up by? It's going up by 4. So when we would find the rate of change, we're going to do 4 over 1. By the way, that's an equal sign and not a z in there. Alright, and so you actually need to look at your units to figure out what does this rate of change mean. Okay, and that would be feet on top. We walk 4 feet for every 1 second. Okay, so the question, what is the rate of change from the data in the table? It's 4 over 1, or just 4. And what does it represent? Well, hopefully you know that feet per second represents a speed. So 4 feet per second would represent the speed of the person. So use this table and find the rate of change. So the first thing you need to do is find, I would probably just find the change in this case of h first, since it's on the left. So we're going up every time by 2. And what about the rate of change on the y? That one might require a calculator. 152 minus 76 is 76. So it's going up by 76 every time. And so when we want my rate of change, it's going to be delta y over delta x, which is going to be 76 over 2. 76 over 2 is 38. And what does it mean? Let's put some units on it. Miles per hour. And so it means that I have this speed of miles per hour, 38 miles per hour. And remember, delta y over delta x, remember we've been calling that k, just to pull that together there. Alright, why don't you see if you can figure out this one, so go ahead and pause the video. Okay, so I figured out that the change in y is 48, the change in x is 3, 48 over 3 is 16, and what that means is 16 square inches per tile. Okay, and so that would really mean the size of each tile. Each tile is 16 square inches, so as I add each tile, I'm adding 16 square inches of tile to the floor. Alright, so here we have a graph that is the number of U.S. passports issued from 2000, 2002, 2004. And the first thing we want to do is find the rates of change for those two time intervals. So I'm going to go ahead and call it K. This is going to be from 2000 to 2002. And so if I look at my y values have gone down 0.3. And so how you would find that is what you usually want to do if you're finding a change in y is you want to do a second value minus a first value. So I'm going to do 7 minus 7.3 over 2002 minus 2000. And then what I'm going to get is a negative 0.3 over 2. Okay, and I'm going to put that in my calculator. And I'm going to change it to a fraction. And it's going to be negative 3/20. Now, if you don't have a calculator that does that, this decimal place is what you can't have, because you cannot have a decimal in a fraction. So multiply by 10 and by 10. That would give you 30 over, actually, sorry, it would give you 3 over 20, which is what we have. So there's my rate of change from 2000 to 2002. And then I want to find my rate of change from 2002 to 2004. So from 7 to 8.9. So this time I'm going to do 8.9 minus 7, because that'd be the second one minus the first one. And that would then be over 2004 minus 2002, which is going to be 1.9 over 2. And again, I can't have that decimal, so if we multiply them both by 10, we're going to get 19 over 20. Okay. Explain the meaning of the rate of change in each. Isn't that nice that the picture's over it? So in each situation. So the first one, what does that negative sign mean? Well, that negative sign means that the number went down. And it actually would have gone down 3 for every 20 years. Or actually, if we look at our units here, it's going to go down 3 million for every 20 years. Okay, and so the 19 over 20 is going to say it's going to go up 19 million for every 20 years. And so in that one, since it's positive, we're going to be going up. Alright, referring to this graph, without calculating, find the 2-year period that has the least rate of change, and then we're going to calculate to verify. So looking at that graph, from 96 to 98, 98 to 2000, 2000 to 2002, which one has the least rate of change? Well, I would say by looks of it, it would be from 98 to 2000. And the reason is because that one looks flatter than anything else. They're all 2-year time intervals, and so if you just find how much they changed by, so like this one went up by 3. This one, next one went up by 2.8, and I think you can tell by looking at it, the last one goes up by considerable more, so this one has the least rate of change. So next we're going to go into slope, and the slope is the ratio of the y-coordinates to the change of the y-coordinate to the change in the x-coordinate, which is your rise over run. And the number itself describes how steep a line is. And when we talk about how steep a line is, we want to take the absolute value of a number. So a number with a slope of 3 and a slope of negative 3 actually have the same steepness. It's just one line is going this way and the other line is going that way, but if you're skiing down that hill, it's the same steepness going either way. And your slope does need to be a fraction, unless you're dealing with a word problem that maybe wants a decimal, and no mixed numbers. So if your slope is, and remember we use a little m for slope, if your slope is rise over run, I have to have a rise and I have to have a run. So if I'm putting in a makes number, what is my rise and what's my run? Okay, so we really have to keep it as an improper fraction if it is one. So if you're given 2 points, we have what's called the slope formula. M equals y2 minus y1 over x2 minus x1, and see how that fits right into the change in y over the change in x from what I told you the change in y was on the previous slide here. You're going to need to have that formula memorized. Okay, and we have 4 types of slopes we can look at. If a line rises to the right, it's called a positive slope. If a line falls to the right, it's called a negative slope. If a line is horizontal, we say it has 0 slope. And if a line is vertical, the slope is undefined. Notice there is no slope anywhere. No slope is never an answer. We repeat that. No slope is never an answer. There is no slope. You either have 0 slope or you have undefined slope. Okay? One thing that reminds me that a horizontal line is 0 is because you can make a Z out of it. And a vertical line is undefined because you can make a U out of it. Just a little help there. So the next thing we're going to do is we're going to use that slope formula. We're going to find the slope that passes through 2 points. I'm going to suggest that until you have the slope formula memorized, you write it out. So there's my slope formula. Now, one of your points needs to be point 1 and one of your points needs to be point 2, but it doesn't necessarily depend which one. So if this was x1, y1, and this is x2, y2, all you're going to do is plug in the numbers where they go. So y2 is where I'm starting, so starting here with y2. y2 is 5 minus 2 over x2 is 5 minus a negative 3. You're going to work this out. So it looks like we have 3 over 8. That cannot be simplified, so there you go. Alright, same thing. Again, I would write out the slope formula. And it's up to you, if you want this one to be 0.1, this one to be 0.2. If you don't want that, switch them. You're going to get the exact same answer, I promise. Okay, so this is going to equal y2, which is negative 8, minus y1, which is negative 4, over x2, which is negative 2, minus x1, which is negative 3. So we're going to get negative 4 over 1, and you can leave it like that or change it to negative 4, either way. Okay, we got 2 more like this. So again, let's write out the slope formula. I think that more often you write it out, the more likely you are to remember it. Okay, so what are we going to have here? 4 minus 4 on top, and on the bottom, 4 minus a negative 3, and you can change that to plus 3 if you want. 4 minus 4 is 0, and then on the bottom we have 7. Now what is 0 divided by 7? It's 0. You have to simplify that to be 0. By the way, I always say that it is okay to have 0 on the top. So one more like this. Again, I'm going to write out my slope formula. Okay, and what do we have on top? We're going to do 3 minus a negative 4, and on the bottom, negative 2 minus a negative 2, alright. Switch some minus negatives to plus positives. We get 7 over 0. So what is 7 over 0? That is undefined. You cannot divide by 0. So you have to change it to undefined. That is what the slope is. That's going to tell you this is a vertical line. By the way, I say no, you cannot divide by 0. Alright, something a little bit different. Find the value of r so that the line through 6, 3, and r2 has a slope of a half. Okay, so I'm actually finding one of my coordinates in one of my ordered pairs. So, let me suggest you start out with writing the slope formula. I would write all of it, that includes the m equals, because here's what you're given. You're given an x1, a y1, this is x2, y2, and an m. And then you need to plug in everything. So m is 1/2 equals 2 minus 3 over r minus 6. Okay? This is a proportion. How do you solve proportions? You cross multiply. So we're going to multiply this way and we're going to multiply this way. So the first way with the 1 times r minus 6 is r minus 6 equals 2 times 2 minus 3. And actually, let's go ahead and simplify. 2 minus 3 is negative 1. So 2 times negative 1 is negative 2. Add 6 to both sides. R equals 4. Alright, so then if you wanted to check this, put 4 in for r up here and then do the slope of these two ordered pairs and you should get a half. One more example. So same deal, find the value of r through these 2 points. So again we have an x1, y1, and x2, y2, and we have an m. So I would suggest you write out your equation, the entire equation. I know it gets boring, but write it out anyway. Okay, so m is 2 equals y2, which is r, minus y1 is 4, over x2 is negative 1 minus x1 is 1. So and you could simplify. This is going to be 2 equals r minus 4 over negative 2. Does that work? Negative 1 minus 1, negative 2. Multiply each side by negative 2. Negative 4 equals r minus 4. Add 4, I get r equals 0. Alright, that's your 4-1 lesson. Hopefully you took good notes. Remember to post to the blog if you have any questions, or write them down and come see me. Have a great day.